This content is brought to you by BEC Financial Technologies, developing and operating IT for Danish banks.
This is a session which is going to be about recent enhancements, and there are going to be a bunch of APAR numbers because the majority of new features that we deliver in Db2 for utilities are not associated with a function level. But for every single item that I talk about here, I will either give you an APAR number or I'll give you a function level, so you know when you can take advantage and how to take advantage of what I'm talking about. So I'm going to start with the Reorg utility. And the first item here is one that, it's an old APAR number for those of you who are familiar with APAR numbers, because we've been on PH for quite some time and away from PI. But that just means that we opened the APAR a long time ago, and it took us quite a long time to actually get around to fixing it. The problem here is to do with partition-level inline image copies for the Reorg utility when we're reorging multiple partitions. The Reorg utility has had support for partition-level image copies for many years. There's no keyword reorg parameter for the creation of partition-level image copies. The way you choose whether you want to use whether you want partition-level image copies or not is by specifying an ampersand PA or ampersand part variable for the template for the image copy dataset. If you do, then you will get partition-level image copies because the Reorg utility knows that the image copy dataset name has the partition number in it. Okay, so it's that simple. And there are various reasons why you might want part-level image copies. So instead of, when you reorg 1,000 partitions, having one huge image copy dataset containing all the data for all 1,000 partitions, with part-level image copies, you have one image copy dataset per partition. It's much easier to manage. But perhaps even more important than that is the performance benefit that you get for recover of individual partitions. Because if you have an image copy dataset that contains all the pages for 1,000 partitions, and you want to recover partition 5, it will work. The recover utility will go and find that image copy, but it then has to scan through the whole image copy dataset, looking for all the pages belonging to partition 5, okay? And that can take a long time, as opposed to having an image copy dataset that only contains the pages for partition 5. So the restore phase for the recover utility is going to be much quicker when you're recovering individual partitions if you're using part-level image copies. But there's a problem. There's a problem with part-level image copies for Reorg. And that problem is that every inline image copy dataset for Reorg has got to be open for update at the same time. So if I am reorging 1,000 partitions and I have part-level image copies, that means you've got 1,000 image copy datasets that are all open for write at the same time. So that's okay if you're putting these on disk, but it doesn't work if you're putting these on tape, because now you need 1,000 tape units, and that creates a problem. So that has always been a restriction for us in the Reorg utility for many years. But it really became a big issue when we delivered PBR RPN in version 12 of Db2, PBR relative page numbering in version 12. Because with PBR RPN, there is actually nothing in the page number that tells, there's nothing in the page, in the data page, that tells us what partition that data page belongs to anymore. Okay, that's the big change for PBR RPN that gives us much greater scalability. So then that became an issue because we couldn't mix partition 4 and partition 5 pages in the same image copy dataset because all we knew was it was page 57 and we didn't know whether it belonged to partition 4 or partition 5. So as a result of that, with PBR RPN, when we deliver that in version 12, we said you have to use part level image copies for PBR RPN reorgs. And so in the early days of version 12 of Db2 in 2016, we had customers saying, I want to convert from PBR APN to PBR RPN. I've got 4,000 partitions and I can't. It won't work because I want to put these image copies on tape and I don't have 4,000 tape units. So our response was, well, go and put the image copies on disk then. And the customer said, no, I don't want to put these image copies on disk. I want to put them on tape. This is your problem, and you need to fix it. And so that is what we have now done here. With a new IC limit tape parameter, where now you just tell us how many inline image copy data sets you want, and we will go and create that number of inline image copy data sets. So you can be reorging 4,000 partitions, and if you say IC limit tape 4, you will get 4 image copy data sets with 1,000 partitions in each image copy data set, okay? And so through this, we've actually removed the requirement for part level inline image copies for PBR RPN. I know what your question is going to be, Richard, but ask it anyway. Yeah, go on. Oh, okay. That wasn't the question I thought you were going to ask. Yeah, I think actually for PBR RPN, for those large table spaces, I think they did actually wait. I think they did actually wait for us to deliver this. Yeah. As opposed to just sticking it on disk and then using HSM to migrate it off afterwards, which they could also have done. Mm-hmm. I know, and then go back to tape afterwards. Ah, dearie me. So anyway, we actually had to change the structure of the inline image copy data sets a bit with this because we still don't know. We still can't look at a data page and tell which partition it belongs to anymore with PBR RPN. So in order to get around this, we actually have to store additional header pages for partitions in the inline image copy data set in order to be able to tell that the following data pages, which partition the following data pages belong to, all right? But if you've got inline image copies for reorg, you're pretty well used to having duplicate pages sitting in the image copy data set anyway, right? I mean, there's a reason why the inline image, you can have a table space or a partition with 1,000 pages, and you reorg it, and your inline image copy data set has got 1,050 pages in it. Because there are some pages that we have to copy multiple times because of updates that occur to these pages during the log phase. Anyway, so we delivered this, and because we were delivering this, we thought nobody's asking for this, but because we like things to be nice and neat and tidy, we deliver the same thing for taking image copies to disk as well. So now, regardless of whether you're taking inline image copies to disk or to tape, you get to choose exactly how many inline image copy data sets you want for reorg. There's still a minimum number of inline image copies data sets that are required, okay, for reorg. So you can't, for example, specify IC limit tape 1 when you're reorging a PBG with a lob column, because the reorg of a PBG table space with a lob column is going to want to move rows between data partitions. But we can't move rows between data partitions without moving its corresponding lob from one lob table space to another. So the reorg utility, when you're reorging a PBG with more than one partition, is by default going to pull in and shadow all of the lob table spaces as well. And although we can combine multiple partitions into a single image copy data set, there is no concept of combining multiple table spaces into a single inline image copy data set. Okay? Right. So now on to the next item here. This is an enhancement that we made in PH 33864 to improve application availability, to reduce the application impact of running online reorg by reducing the duration of the drain, okay? The total duration of the drain for online reorg. It's not reducing the duration of the switch phase, it's reducing the duration of the drain itself, the total drain itself. So, so the way online reorg works, just briefly, is when you start your reorg, we go and create the shadow data sets, and your data is read-write. So applications are still reading and updating the data. And we unload the data from the original data sets. Then we sort that data into clustering order, and we go and load that into the shadow data sets. So this takes some time. And then once we're done with that, now I've got to go back and start reading the log, because I now need to go and process all of the updates, the application updates that have been occurring while I've been doing all of that work. So that's the log phase that we start on. And so we start reading the log then, and we have multiple log iterations because we read the log to the end of the log, and then we process any updates that we find. And then by the time we finish processing those updates, well, now the log has moved on a bit. So now we go and read to the next end of log and process those. And then we read to the next end of log and process those. And eventually we get close to the end of the log. We're sort of catching up on the end of the log, and the amount of log data that we have to process becomes less and less and less. And eventually we hit a limit called max RO. There's a parameter in Reorg called max RO, which says, how close should I be to the end of the log before I try to get my drain? Okay? And at that point, I'm going to try to get the drain. And then there's another parameter called drain wait that says how long I should wait trying to get the drain, wait for applications to commit and release their claim so that I can then get my drain. Now there cannot be any more updates on the log. So now I just need to catch up that last little bit on the log. And then once I've done that and processed that, now I can enter the switch phase, switch the data sets around, and allow applications back in again. Does that make sense? So that's how Reorg works. So this customer in Australia a few years ago said, I have specified max RO and drain weight, and based upon those parameters, I expect maybe a 30-second total drain duration. And yet the drain was being held for 2 minutes, and my lock timeout interval for my applications was 60 seconds. So my applications are timing out on the reorg. Whereas if I'd finished in 30 seconds, the applications would not be timing out. They wouldn't notice it. So we had a look at this to figure out what was going on. And the problem was not the duration of the drain. Sorry, it was not the duration of the switch. And we got the drain. We got the drain fine. The problem was that once we'd got the drain, now we catch up that last little bit on the log. And we found some updates that had to be applied to the shadow dataset. So we go and apply those updates to the shadow dataset. And then once we've done that, we know that there have been some changes now in this last log iteration to the shadow dataset. So now we've got to go and scan the shadow datasets looking for those changed pages. And then we need to go and take those changed pages and put them into the inline image copy. Okay? And their DASD performance, their disk performance was poor. So the scan of the shadow datasets was taking a very long time. So to fix this, we delivered a new last log no option, which basically says, I've got my drain. Now I'm catching up the last little bit on the log. If I find any updates to be processed, stop there, go back and release the drain. Let the applications back in, and I'll go and try and get the drain later on. I'll just go back and carry on doing my normal log iterations, and at some point, I will try to get the drain again, in the hope that I eventually get the drain, and then in the last log iteration, I don't find any updates to process, okay? So with this option, what we're doing is we're minimizing the amount of work that the reorg utility has to do while it's holding a drain that is blocking applications from accessing the data. But if you specify this parameter, what you are saying is that minimizing application impact from reorg is more important than the success of the reorg itself. Because a normal reorg, like the reorg that you're all running today, once we've got the drain and we've succeeded in getting the drain, that's it. Now we're motoring through to completion. I mean, unless you go and cancel the job. But now what we're saying is I can get the drain and I can still release it and have to go back again. And then eventually you might run out of retry attempts because the default number of retry attempts that we do for a drain is 6 for reorg. So if you're going to do this, I would recommend increasing the retry from the default of 6 to something like 10 or 12, just to give us more of a chance to succeed. And consider reducing max RO, because if you reduce max RO, you are going to be reducing the amount of log that we are scanning once we have got the drain. Okay, so it reduces the likelihood of us encountering any updates against the page sets that you are reorging. And of course, think about running it during a quieter time of the night, or whenever you're doing this. The other thing to say about it is, the issue here is inline image copy processing. So, if you're using dataset level flash copy, if you're using flash copy for your image copies in reorg, then this isn't going to do you any good, right? This doesn't matter, because you're never going to have this problem if you're using flash copy image copies. Because with flash copy image copies, you don't need an inline image copy. We're just going to take a flash copy when we enter the switch phase. Okay? Does that make sense? Yes, question. Yeah, well, okay. I can't remember the exact value that they had. But basically, they had drain weight and max RO set in such a way that they expected the total duration of the outage to be 30 seconds. And their lock timeout interval was 60 seconds, right? So that works, right? Because if we can break in and get all of our work done and get out of the way in 30 seconds, and your applications have got a lock timeout interval of 60 seconds, then those applications that are waiting to try to get a claim and waiting behind the drain, they're not going to time out because they're only going to time out after 60 seconds because that's the timeout interval. Okay? Okay. Yes? In the last log iteration, yeah. Yes. That's like a redesign of the mapping table, and it might be one page, it might be 10,000 pages. I mean, when we go and do this update, right? When we go and do an update of the shadow, we're using standard Db2 internal mechanisms to go and run that update and apply that update to the shadow dataset. So it's like an insert. It's something like we see a log record that inserted into the original page set. We're going to go and drive insert processing into the shadow page set. we don't actually know which, and we don't keep track of which page we've actually inserted into, which is why we go and do that scan. We actually talked about maybe we should change the logic to actually track and keep track of the actual pages, the actual change pages. But that was going to be a ton of work because we have no idea whether we're talking about 0 or 1 million, So we didn't go down that path. We did not go down that path. Flash copy, right? Flash copy. Okay. So the next item is a big performance improvement for Reorg Index. Reorg Index would unload the index keys from the index in key order, right? So it's a reorg of the index, but there is no sort. There is no sort going on. We just unload the index keys in order, and we would write those to disk, and then we'd read them back in again and put them into the shadow. So what we've done now with a new no sysut1 option and a ZPalm is we've said, just don't write this to disk, just pass it in memory, go and load into the shadow, and we also support parallel unload and build processing of index keys as well. All of it in memory now with this parameter. We gave it to a customer pretty early on when we delivered this. This customer got 80% elapsed time improvement and 60% CPU reduction by specifying this for Reorg Index. And we decided that when we delivered this with a PTF in version 12, that in version 13, we're going to just ignore what you specify. So for us in version 13 from M500 onwards, it doesn't matter whether you specify the parameter or whether you specify the ZPalm, you will get this behavior. And then the next version of Db2, we're just removing the ZPalm. ZPalm isn't even going to be there in the next version of Db2. So it's a big, big performance improvement for Reorg Index. Just by, if you don't do anything at all and you just go to M500 and version 13, you will get it anyway. All right. Yeah, as I mentioned the sort thing because one of the concerns that a customer raised with me about this was, is this going to be chewing up a ton of memory doing this? It uses up virtually no memory at all because there is no sort. So it's not like we're using df sort and using up, 500 megabytes of memory for sort processing. There is no sort. Onto the load utility. There's a new force option for the load utility, just like we had a force option for the reorg utility and have had for years. We've now delivered a force option for load, which allows the load utility to cancel threads that are preventing it from getting a drain to break in on applications. And just like the reorg utility, you get the same options. There's force none, which of course is the default. You can force readers or you can force all threads. Canceling a thread that has been reading without doing any updates is cheap. But if you use force all, you're telling the utility that it can cancel a thread that has been performing updates, not just against this page set, but we actually look to see if it's performed any updates against any page set, all right? And if you do that, and that thread has been updating for the last 5 hours, now it's got to roll back 5 hours worth of work before it can release its claim. So you need to be a bit careful about whether you decide to use force all here. But nevertheless, we thought it was a useful option to make available, and a recent APAR introduces a serviceability message for both load and reorg to tell you what type of cancels are being done here. In addition to that, on the load utility, we now deliver consistent inline image copies for load. The load utility would create an inline image copy containing the data that is being loaded. But the problem with it is that if you have a referential integrity constraint or you have a unique index on the table, then we will load data into the table, and then afterwards we will go through an index val phase for unique indexes or an enforce phase for RI constraints. So it might be that we loaded 100 rows into the table, but then after we've loaded 100 rows, we go and check, and we find that actually 5 of those rows violate the unique index constraint. So we then go and take those 5 rows out again. So actually, you wanted to load 100, but you only loaded 95, and 5 of them got discarded. But the inline image copy that we created still had the 100 in it. We never went and fixed up the inline image copy dataset. So as a result of that, if you go and have a look in the manual would say that the inline image copy dataset that we created for load could not be used for recovery purposes, which, to be perfectly honest, is the main purpose of having an image copy in the first place. So we fixed this now with this APAR. There's no parameter or anything like that. The load utility will just do it automatically, so that now you have an inline image copy dataset that actually is consistent and can be used for recovery. And there's a new T-type value in syscopy of V that indicates that this is an image copy that can be used for recovery. Then the second one is better partition serialization by the load utility. So say you have a table space with 100 partitions, and you want to load 5 partitions. You can choose then, do you want 1 image copy dataset, or do you want 1 image copy dataset per partition? If you specify the copy DDN at the partition level, you'll get 1 image copy for each of those 5 partitions. But if you want 1 image copy dataset for all of it, then you specify the copy DDN at the table space level in the load syntax. But the problem with that was the copy DDN at the table space level meant that actually we'd end up serializing on the entire table space, even though you only wanted to load 5 partitions. So we fixed that now with this particular APAR here. And again, it's just a matter of putting the PTF on. Better handling of NPIs on load part replace. So if I'm running load replace against a partition, then the load utility has got to go and delete all the index entries out of the NPI for the data belonging to that partition that I'm doing a load replace against. So if I've got 1,000 partitions and I'm running load replace against partition 2, the load utility has got to go and delete all the index entries from the NPI belonging to partition 2, because that data that was there is now gone. And when we're doing that, it might be that we've deleted all the index entries in that index page. So the question is, what should we do with that empty index page now? Do we physically delete it? In which case we can collapse the index tree and make the index smaller, physically smaller. Or do we leave it there because your applications might be inserting index entries later on that use that index leaf page that is now empty, so we avoid the cost of an index leaf page split for your applications later on. So we went back and forth on this, and in the end we decided, you know what, we give up. It's not going to be our decision anymore. So we've got a new keep empty pages option, and the default is keep empty pages yes, because it's the cheapest thing for the load utility. Cheapest thing for the load utility is just leave the empty index leaf pages there. But if you do want us to collapse the NPI down and make it smaller when you run load replace, then you specify keep empty pages no. in which case we will go and physically delete them. Okay? Next one, auto estimation of input dataset size from tape for the load utility. So the load utility uses work date sets, right? Sort work date sets for sorting of index keys, for example. And in order to figure out how much space we need to allocate for these work date sets, we need to know roughly how much data you are loading into your table. If the input data set is on disk, we have a look and we say, well, we know what the table definition is. We know how big the input data set is. So we roughly know how many rows you're going to be loading, how much data you're going to be loading. But if the input data set is on tape, we had no idea how big that input data set was on tape. We don't have to scan the whole input data set, figure out how big it is, and then go back and scan it a second time in order to go and read all of the data. So we worked with DFSMS RMM, which is IBM's tape management system, to use an interface where now we can figure out how big the input data set is on tape, so that now, because we know how big the input data set is on tape, we can accurately predict how much sort workspace we need to allocate dynamically for the load utility. Without it, you would need to use a numRex option where you basically just tell us roughly how many rows you think you're going to be loading. Are we talking about loading 10 rows, or are we talking about loading 10 million rows? Because that makes a big difference. But now with this, if you're using RMM, you don't need the numRex parameter anymore. If you specify numRex, we will use whatever parameter, whatever value you specify. We will not override it. And then a very recent enhancement that we delivered for the load utility, which is actually tied to a new function level, is a new option called no key delete. I already talked about the work that we have to do to go and delete index entries from NPIs for part level load operations. But what this is for is, it says it's a performance improvement, but really it's an application availability improvement. The situation here is that there are a lot of customers who use load replace with dummy input, with DD dummy, to clear out a data partition, because it's a very, very cheap way of deleting all the data from a Db2 partition, tablespace partition. Because load replace with dummy input, we don't go and delete the data, we just go and reset the data set. Okay? It doesn't matter how much data was there. We just reset the data set for the partition, and we reset the data set for the partitioned index as well. But the NPI, we can't do that. The NPI, we've got to scan the whole NPI, looking for all of the index entries for this partition to go and delete those index entries one by one. And that can take a long time. And the worst thing about it is, while we're doing that, the logical partition of the NPI is in rebuild pending. And that then impacts applications that are reading the data through the index, even though ultimately they're not looking for data in the partition that is being replaced, that is being reset. Okay? So there's an application impact to this. So what we have done here now is we've delivered a new no-key delete option specifically for load replace of a partition with dummy input. Okay? Just for this scenario here. And what this says is skip the NPI processing. Just forget about tidying up the NPI. Leave those index entries there. Instead, we will put the logical partition of the NPI in RBDPM state. Rebuild pending, and then M for empty. Okay? That then means that an application coming in and reading index entries from the NPI, when it comes across an index entry for that partition, we know, Db2 knows it's in RBDPM, and we will just ignore it. We'll ignore that index entry, okay? We'll just treat it as if it didn't exist. So this way, we've massively sped up the performance of the load utility, and we've eliminated the application impact, where previously the logical partition might have been in rebuild pending for 30 minutes, 2 hours, depending upon how big this NPI is, okay? Yes, Richard. Same thing. So the question is, what happens with a select that's index only, that isn't even accessing the data? It's exactly the same thing. We're just reading through the index. We don't need to access the data at all. Reading through the index, any index entry belonging that belongs to this logical partition, we'll just skip it. No. We know. We know because the index. Yeah, sorry, I got it. Yeah, so the question is, for an index-only access, when we come across an index entry belonging to this logical partition, how do we know? How do we know to skip it? How do we know it belongs to this logical partition? And the reason is that the index entry has got not just the index key, it's got the RID of the data row. So we know that index entry, or at least that key RID pair, which data partition it belongs to. And so we know that data partition is that logical partition is in rebuild pending RBDPM, and so we know we can skip it. So we know that. Trust me, it works. It works. It really does. So that means that we've eliminated the impact for SQL read. We've eliminated the impact for the load utility. Okay, the logical partition's left in rebuild RBDPM, rebuild pending empty, and because there are a bunch of index entries there in the NPI that really shouldn't be there, we will not allow any new inserts into that data partition until you've gone and removed that RBDPM state, because we can't be in a situation where the NPI has got a mix of index entries that we want to keep and index entries that we are like obsolete and old, okay? So you just have to manage this, because removing the RBDPM state, you can do it through reorg index, reorg tablespace, either tablespace or partition. If you want to, you could rebuild the index, but I don't recommend you could use rebuild index. I don't recommend it, because when you run rebuild index, that is the index or the logical partition is going to go into rebuild pending now. And part of the point of this was to avoid the impact of rebuild pending in the first place. And if you're really brave, you can use repair and just go and reset the RBDPM state, right? But as you would imagine, I don't exactly recommend that either. But the performance of this, though, we ran it 30 partitions, 180 million rows, 4 NPIs, without no key delete, 40 seconds. With no key delete, 0.2 seconds. 0.2 seconds. And the nice thing about this, well, one of the many nice things about this is it doesn't matter whether, if this table had 180 billion rows instead of million rows, instead of 40 seconds, this would maybe have been 4 hours. I don't know, But I know that this would still be 0.2 seconds, because it doesn't matter. It doesn't matter how much data was in the partition. It doesn't matter how many index keys were there. We're just skipping them altogether. Okay? Okay. And because it's a new because it's a new exception state of RBDPM, it's tied to function level 506 in version 30. Okay. All right. I only have one slide one item for the copy utility, but it's a pretty useful one, and that is basically up to 50% offload to zip for the copy utility just by putting a PTF on that we delivered at the end of last year. Okay. for version 13. And it's easy. I mean, the thing about the copy utility is each copy utility does not use an awful lot of CPU, but it for sure adds up because you're running a lot of them all the time. And it's easy to see. It's easy to see this because the utility history table in version 13 has got total CPU consumption and total zip offload as well. So you can easily go and run a query today and see whether you even have this PTF on. The recovery utility, the main one I want to mention is redirected recovery. How many people here have tried redirected recovery? Everybody? Okay, a couple of people. So the recovery utility, ever since 1.1 of Db2, has had one job, and that is recover my data in case something has gone wrong. Now, with this, it's completely changed the use case for the recovery utility by massively expanding it. Now I can use the recovery utility to say, I want to recover this object here over to this target over here, to a completely different page set, or table space, index space, lob table space. And do that without impacting the original source page set, okay? So you can take your production table and you can recover it over to some other table without impacting your production applications. So you can use this for testing recovery time estimation. How long would it take me to recover if I had to recover for real? Or am I truly recoverable, right? I can actually now go and run the real, because this is the real recovery utility. It's the real recovery utility, same code path that's going through doing the same restore phase, the same log apply. It's the same log apply as if you're running recover for real, okay? But the one that's got most people interested is forensic data analysis, because now you can have a business area that says, I want to know what the content of this table was as of midday yesterday. And you can just go and run the recover utility to recover this production table to midday yesterday and put it into some other test table, and the business area can go and analyze that for the next 6 months if they want to, right? And we've had customers who have used this for situations where they've accidentally gone and deleted 5 million rows from the table, right? Well, once you've done that, unless you detect it immediately, your applications and your business logic has carried on running. So you can't just detect this 5 hours later and then go and recover back to a prior point in time, because your applications have carried on updating based upon the data as it is now. But from a business perspective, you want to see what the data was at the time those rows were deleted, so that you can then do some comparison and decide whether you need to take some action to fix any logical inconsistencies. And this allows you to do that as well. So you can do it's the recover utility, so you have the same options as for a normal recover. You can recover to current, or you can recover to some prior point in time, an RBA or an LRSN. But if you recover to current, it's still going to be a point in time recovery for the recover utility. Because if you start, say it's like 2 p.m. and you start the recovery now, we will recover you to 2 p.m. even though it takes 30 minutes to run, for example. But because it's all point-in-time recovery, the recovery utility will always make sure that the data at the target is transactionally consistent. Because ever since version 9 of Db2, a point-in-time recovery for the recovery utility will always make it transactionally consistent. So any uncommitted units of work at the time you want to recover to will be rolled back against the target page set. This is an example, I mentioned this yesterday, this is a good example of how we are not interested in delivering new features for deprecated object types. So this is UTS, indexes, and lobs. XML is UTS anyway. And it supports data and indexes. So the other things to say about it, the syntax is very, yes? Yeah. Oh, that's probably, actually now that's probably like 2 years ago that we delivered it. So unless you're telling me you're on like RSU 2206, you probably have these on. You should have these on now if you're reasonably current in maintenance. Okay? All right. The syntax is simple. Recover table space, target from source. And we deliberately did it that way because if we did recover table space source to target and you accidentally forgot about the to target bit, now you're recovering your production table by accident, which nobody will thank you for. Then we delivered 2 new messages with this. One of them says the point we're recovering to, and the second one says how many log records we've read and how many log records we've actually applied. And we decided these messages were so useful that we made them available in any recovery. So just by putting the PTFs on, even though you're not doing a redirected recovery, any recover will now get these messages in the job output. There's a new translate phase because we have to translate OBIDs just like DSM-1 copy would with OBID XLAT. And the target is placed in copy pending after the recover because over on the target, there is no recovery base anymore. So you have to decide whether you care about that or not, okay? So recommended actions, repair catalog, run copy to create a recovery base, rebuild any indexes, run check data. You can choose whether you want to do this or not. Okay, it's entirely up to you. And the last item here is table space level recovery from part level image copies will now work automatically in version 13 of Db2. In version 12 of Db2, if I want to recover a table space and I only have partition level image copies, it won't work because the recover of the table space required a table space level image copy data set. In fact, it could work, but the only way it could work is if you know that you can specify a part level parameter on the listdef and use the listdef with a part level parameter for that recover. But most people don't know that, and the people who do know it will probably forget it. So we had to fix it, and we fixed it in version 13. So now I can say recover the table space, and maybe I've got a table space level image copy, and then I've got some more recent partition level image copies. We'll just go and merge them, and it'll be more efficient. Runstats. We are keen to promote the use of page sampling instead of row sampling for gathering statistics. And in version 12 of Db2, from function level 505 onwards, by default, we are going to override row sampling to use page sampling with a default page sampling with an auto sampling rate. Okay? If you leave this ZPalm alone. If you don't want us to override it, you'd have to change the ZPalm to no. But the default is we would override it from 505 onwards in version 12. In addition to that, we support now page sampling for inline statistics as well in version 13. And we have what we call dynamic profile support because in the future, we expect to see more and more use of statistics profiles to define what statistics you should gather for a table. So if you run Runstats and you say use profile to gather these statistics, what what about the other statistics in the Db2 catalog then for that table? What do we do with them? Well, what we used to do was just leave them alone. But the problem with that is you then have a mix in the Db2 catalog of new statistics and old statistics. And the Db2 optimizer generally does not like a mix of current and 3-week-old statistics for a table. So what we've done here now is we said, if you're running Runstats with use profile, we will go and remove all the extra statistics that are not actually part of the profile. And before anybody asks, we don't go and delete the statistics at the start, so you have like a 5-minute window of no statistics in the catalog. We go and tidy this up as we put the new statistics in. Okay, some general enhancements that we've delivered recently. We've delivered a PTF here very recently this year that removes an unnecessary forced write against sysutils. When we commit the utility, which could be intermediate commits or it could be at a phase change of the utility. Because we've had a number of customers complain about contention in the sysutils table space in the Db2 directory when you're running a lot of concurrent utilities together. So we're studying this and figuring out what we can do in order to improve it. And this was one of the items that we thought, let's go ahead and do this now. At the same time, we're looking at restructuring sysutils because the sysutils table space has got 2 tables in it today. That's not going to work in the future when we switch to PDUG. So expect in the future that we are going to be delivering a catmate in version 13 to convert the remaining catalog and directory table spaces to PDUG, and that means we're going to be splitting out sysutils into 2 separate table spaces. And the other item here is better estimation for DSM comp to decide whether you should compress or recompress page sets. There's a reorg, DSM comp has a reorg option, and the whole point of the reorg option is to tell you whether you should go and run a reorg in order to get better compression than you have today. But the problem was that the algorithm that DSM comp was using was completely different to the algorithm the reorg utility was using. And so as a result of that, you look at the DSM comp output and you think that you're going to get better compression by running the reorg, and then you go to the trouble of running the reorg and you don't actually get that better compression. So we had to fix this to make it mimic the reorg utility so that now when you run DSM comp, you can be reasonably assured that what it tells you you're going to get, you will actually get when you run reorg. And and there's a new externalize Huffman dictionary option that allows us to externalize the Huffman dictionary just like we have the ability of externalizing the Ziv-Lempel dictionary from before, if you're interested in that capability. And there's a new ZPalm to prevent modify recovery from deleting image copy datasets. Years ago, we had complaints from customers saying, I run modify recovery to delete information from syscopy and from syslogrange, but the image copy datasets are still there. So I want modify recovery to delete the image copy datasets as well. So we delivered a delete DS option for modify recovery, where if you specify it, the modify recovery utility will delete the rows from syscopy, and it will delete the image copy datasets also. But the latest complaint from customers on this subject is, okay, that's fine, but from a compliance standpoint, we cannot have just anybody go and specify delete DS on modify recovery and go and delete these image copy datasets. We need to control the deletion of image copy datasets in our environment. So we've now delivered a new ZPalm that basically says, I don't care if anybody specifies delete DS. We will ignore it and we will keep these image copy datasets around. Okay, so override the delete DS option for modify recovery. Utility history table. This is something that we delivered phase 1 of in version 13 in M501. It's a new sysIBM.sys utilities table in the Db2 catalog, and it contains one row for every utility execution. So I run the copy utility, and I'm image copying 1,000 table spaces. You will have one row that says, this is the copy utility that ran, this is the job name, this is who ran it, this is when it ran, this is how long it ran for, this is how much CPU it used, how much zip it used, and whether it completed successfully. Just basic information like that about each and every utility that executes in Db2. So now you have a complete history of all the utilities that are executing in Db2. And there's a new event ID column which is an event ID that uniquely identifies this utility execution. And we added that event ID column to syscopy as well. So now you can correlate the row in sysutilities with the rows in syscopy if this utility puts and inserts rows into syscopy. And the design principle of this is that the utility history gathering should not impact the utility execution itself. So for example, if you went and stopped this table space in the catalog, that means we cannot insert anything or update anything in the utility history table. But it is not going to affect the execution of the utility at all. The utility would still end with a return code 0, because we don't want our inability to insert or update into sysutilities to cause your recover to fail, right? Your data recovery to fail. And here you can see the utilities that are supported and the utilities that are not supported, which I'm hoping makes sense, like options is technically a utility. Listdef is technically considered a utility, but it makes no sense to have a row in sysutilities for a list separately for listdef. And things like dsm on copy doesn't even have to have db2 up to run. So that was phase 1, and we always knew that that was not going to be good enough. So in 504, we delivered phase 2 of utility history, because although sysutilities will tell you that you've run a copy utility or a reorg utility or Runstats or load or unload, it doesn't tell you what objects that utility operated against. That's what we do now with object level support, with a new sysobj event table in the catalog, so another catalog table. Again, it's got an event ID column, so you can match this up with sysutilities, and it has one row for every page set that is touched by every utility. So now I can run a query that says, show me the complete utility history for this table, or this table space, this index space, whatever it happens to be. And you can get that now easily through querying these tables here. And we have a couple of indexes on them. You can go and create your indexes to your heart's content. Yeah. Yeah, so catmate, so the question is, why isn't catmate supported? We decided not to support catmate itself, but the catmate job is probably, say, might be creating some new tables, creating some new indexes, adding columns to existing tables. It's doing various pieces of work that aren't utility related. However, also included in catmate are going to be things like reorgs of existing catalog table spaces, and those would be registered. So any utility execution that is done by catmate will be in the utility history table. So to give you an example, a good example is the work that we're doing right now to restructure the catalog and directory to be UTS only. that is going to mean using the function that we've already delivered in Db2 to move tables out to separate PBGs. That's the reorg utility, and that you will see. So that piece of the work you will see, because that is directly utility related. Okay? But the other stuff like adding 5 columns to RTS sysindex space stats or something like that, you're not going to see here, because that we don't consider to be utility related. Okay? So here you can see an example of the output that you get in the job output for a utility. Utility history collection is active. The level, because this is utility history collection is controlled by a ZPARM, and you've got 3 choices. There's none, which means we're not going to collect anything, obviously. There's utility, which means only collect utility level and not object level. And then there's object, which says collect utility level and object level. So now we've got object level collection. This is the event ID for this utility execution here. And sysobj events rows have been inserted for object level collection. Okay? So you have information about the event ID and the utility job output. So you can go and match up the job output with the information in the tables in the catalog. So very quickly, very quickly, future work that we're interested in utilities. Reorg performance. I mean, literally everybody wants reorgs to run in like 0 elapsed time, 0 CPU, 0 zip, okay? To be perfectly honest, the only way we're going to achieve that is being smarter about when reorg should run and how they should run. You know, but that's not the real utility's job. That's like automation experts' job to figure that out. But what we want to do, though, is we've got plans to improve partition parallelism, and we've got plans to improve log read processing to reduce the elapsed time, the overall elapsed time for every reorg utility that runs. Load performance and simplification. We want to make some parallelism improvements, because today, if we just forget about load share level change for a second, because load share level change just drives insert processing under the covers. But for a normal load share level none, the only way you're going to get parallelism is through partition processing, partition parallelism. So if I'm loading 4 partitions and I have a single input data set, there's no parallelism. But if I split that input data set up by partition, I can drive 4 load tasks loading in parallel into these 4 partitions. That's how load parallelism works today. Does that make sense? Yes? Yes? So here, the input data for partition 1 is in sysrec 1. The input data for partition 2 is in sysrec 2, sysrec 3, and sysrec 4. So I'm saying load part 1 with this input data here. But it's complicated, because if I go and run a reorg rebalance, so now my limit keys have changed between the partitions. So now I've got to go and change my process here, because I don't want to be in a situation where some of the rows in sysrec 2, some of the records in sysrec 2 don't belong in partition 2, they really belong in partition 1. Well, if that's the case, those rows are never going to get loaded, because they don't belong in partition 2, so they're just going to get discarded. So I'm going to be losing some data then. And say I'm loading 1 million rows here across 4 partitions, but maybe 99% of the data is going into partition 1. Well, these 3 tasks here for partition 2, 3, and 4 are going to finish in 5 seconds, and they're going to have nothing to do. This one here, this poor task up here, has got to be running for another 30 minutes or 10 minutes or however long it takes. So data distribution, skewed data distribution, can impact the efficiency of parallelism for the load utility. So how much better to just say, forget that, I'm going to go with this. So I'm just going to load the table and have the utility figure out how best to parallelize. And by the way, this does not even work for PBG table spaces. There's no concept of loading individual partitions for PBGs, because there literally is no partitioning scheme for PBGs, okay? So it makes no sense to say load partition 2 of a PBG tablespace. With this over here, we can drive parallelism for PBGs in the future. Online rebuild index, I mean real online rebuild index. Rebuild index share level change today. Your data is read-write, but your index is in rebuild pending and unavailable. With this, in the future, we want to support the ability to rebuild an index while that index is accessed by your applications. Further work for integration with CyberVault and more utility history enhancements so that you, and ultimately we, can make much smarter decisions about what utilities run, when they run, how they run. And so, in summary, I hope you've seen, the continued investment that we have in delivering significant new capability in terms of availability, in terms of usability, in terms of performance for the utilities that we've got. Take a look at the IBM documentation. These are 2 great URLs here that contain information about every new feature that we're delivering in Db2 version 13, whether it's utilities or whether it's base Db2, okay? So if you have any interest in any of these items that I've spoken about today, you can find more information about them and all the other stuff that we're doing in Db2 development here. And with that, any other questions? Okay, thank you very much.